The Big Bang, understood as the beginning of time, has an implicit problem called spontaneous generation. How can creation appear suddenly out of nowhere? If we seek to understand the world, if we decide to embark on this quest, we cannot admit anything coming from nothing, because then the hope of understanding what is going on vanishes. In fact, that hope it is the one that is implicit in the energy conservation principle, which precisely states that things are not created or destroyed, but are transformed. If we remain faithful to this principle, we must assume that before the Big Bang there must have been something that ended up being transformed into creation. But what is it? The only thing we can say about it right now is that it is absence of creation. Can we think of any natural cycle where two equally antagonistic natures alternate? Yes, the moon cycle. The cycle of the moon alternates light and shadow, which are also two antagonistic natures since darkness is absence of light. Therefore, let it be assumed for now that the presence of creation in the universe alternates with its absence in the same way that light and shadow do in the phases of the moon. Then, within this analogy, the new moon would be the equivalent of the Big Bang, while the full moon would be the equivalent to a universe in maximum expansion. When we look at the moon, since we look at it from the outside, we can see both its light and darkness. Then one can state that the sum of the dark surface plus the illuminated one always gives a constant value equal to the visible surface of the moon. For instance, suppose that the illuminated part can be deformed into a square of side x, and the same with the dark part, now with the side y. Then the fact that light and shadow combined give the total area can be expressed as x squared plus I squared equals 1. This mathematical expression is also a Pythagorean expression, in the sense that it relates the sides of a right triangle. Therefore, one can express the different faces of the moon by means of right triangles. If these triangles are overlapped, it is seen that as the faces of the moon advance, the vertex of the triangle draws a circle of unit radius. Notice that as the circle is drawn, the cycle of the moon appears twice. That is, in a single turn in this representation, two new moons and two full moons appear. At this point, we'll make an assumption. We'll assume that the faces of the moon can be reproduced through a circular motion at a constant speed, that is, a uniform circular motion. Now we wonder, could we find a similar representation for the case of the universe? The main difference between the moon and the universe is that we see the moon from the outside, and therefore we are able to see both its lit and dark parts. In contrast, in the case of the universe, we only have access to the presence of creation. We only see what it is, while what is not, it is not accessible to us. That is, the absence is invisible to us, and we refer to it as the beyond, to name it somehow. This asymmetry is so because in the case of the universe we cannot look at it from the outside, that is, we are a part of the structure, and therefore the vision we have of it is an inner vision. And this introduces a fundamental difference. In fact, from our point of view, the beyond, or in other words the invisible, seems to us an inconceivable thing, an impossible thing. That is, on the one hand we have a real world, which would be the light in the analogy of the moon, and on the other we have an inconceivable one, which would be the shadow, to which we have no access. And this is a fundamental difference that should be taken into account algebraically. In this sense, the case of the moon is relatively simple, algebraically speaking. If we represent light with positive real numbers and darkness with negative real ones, the antagonistic nature between light and shadow is already contemplated through the sign. In other words, the fact that multiplying less by less gives plus is the algebraic equivalent of the fact that the absence of darkness is light. However, this representation is not sufficient in the case of the universe, because even though the relationship between positive and negatives would be capable of reproducing the antagonism between presence and absence, it would not come to express the fact that from the presence, the beyond is seen as inconceivable. So, how to solve this? We know that the physical reality can be counted using real numbers. Thus, the absence should be expressed with some kind of numbers which, from the perspective of the real ones, also should appear as inconceivable. And do these types of numbers exist? Yes, they are the imaginary numbers, that is to say, those resulting from the square root of -1, which we represent with the letter I. From the perspective of the real, the imaginary unit I is a mathematical impossibility, since there is no number that multiplied by itself gives -1. Therefore, it is inconceivable from the point of view of the real. And on the other hand, the desired antagonism is still maintained, because the product I times I gives a real value equal to -1, which means that the imaginary of the imaginary is real, and therefore, this is the algebraic equivalent of the fact that the absence of absence is presence. Per tant, sembla ser que la presència i l'absència de creació es relacionen entre elles de la mateixa manera que ho fan els nombres reals amb els imaginaris. És a dir, all this can be summarized as follows. If we live in a world that is real, then from this perspective of the being, the beyond appears as something incomprehensible, inconceivable, and therefore all quantities used to refer to it must also be accompanied by an inconceivable in mathematics, such as the root of -1. Thus, everything that from the outside is seen as y, from the inside should be iy. If we add this idea into the expression of the cycle that was found using the analogy of the moon, then the cycle that alternates presence and absence of creation can also be expressed as a uniform circular motion on a plane with one of the axes, that is, the one that is related to the absence, being imaginary. If seen from the outside, the equation of the circle is x squared plus y squared equals 1, now the same relationship, seen from the inside the structure, changes a sign. So what from the outside was a sum is now perceived as a difference. And now we wonder, does it make any sense, this expression? Yes, of course it makes sense. Physicists immediately recognize that it closely resembles the relativistic invariant interval, where x is space, t is time, and c is the speed of light in vacuum. By comparing these two expressions, one comes to the conclusion that what has been so far called presence and absence of creation, or real and inconceivable, or real and imaginary, might manifest physically in terms of space and time, respectively. Therefore, it looks like presence is manifested physically in terms of space, while absence is manifested in terms of time. If this is so, that is, if it really makes sense to equate the internal view of the equation of the circle with the relativistic invariant interval, then the fundamental cycle between presence and absence of creation becomes a kind of rotation in space-time. On the other hand, if this is so, it also follows that the fundamental cycle that alternates presence and absence of creation would not be exclusive to the universe as a whole, but would be present at all different scales, as the laws of relativity are. Per tant, fins ara, les dues conclusions que ens cal tenir clares és que, una, que el cicle es pot expressar a través d'un cercle, o sigui que la geometria associada al cicle és la del cercle, i per altra banda que aquest cercle ens el podem mirar des de dues perspectives diferents, des de fora, tal com hem fet tota la vida, o bé des d'una perspectiva interna, si formem part de l'estructura, o sigui des de dins. I per canviar d'una perspectiva a l'altra, l'únic que ens cal fer és fer que totes les quantitats que siguin referents a l'eix de les is, fer que siguin nombres imaginari purs. Let's see how other properties of the circle change when viewed from this new internal perspective. For instance, let's see how the expressions associated with the rotation transformation change. Given a point on the circle at an alpha angle with respect to the x-axis, so that its coordinates are x and y, then if the point is rotated counterclockwise a theta angle, it will have new coordinates x prime and y prime. Then the rotation transformation is the expression that relates the values of x and y with the new values x prime and y prime. These expressions can be obtained from the trigonometric formulas of the angle sum for the cosine and the sine. If rather than rotating the point, which is initially at an alpha angle, the axes are rotated counterclockwise a theta angle, then we immediately realize that this operation is equivalent to rotating the point a minus theta angle. Therefore, to find the expressions associated with the axis rotation transformation, one just needs to replace theta by minus theta in the point rotation expressions. Once these expressions are found, we need to apply the internal perspective to see how they are observed from within the structure. That is, we need to change all the values that refer to the y-axis to imaginary values of the type iy, and not only in these two expressions, but also in the definitions of the sine and cosine. We write a star cosine and a star sine to indicate that they have also undergone some change. Then we'll see which one. How have the sine and cosine changed? Well, in the same way, we know that the classical definition of the cosine is the contiguous side divided by the hypotenuse, while the sine is the opposite side between the hypotenuse. Therefore, we need to change everything that refers to the y-axis, which in this case is the opposite side b, to a pure imaginary value of the type ib. This makes the new sine and cosine star functions to be the same as before, but now with a squared minus b squared at the square root and with an ib at the sine numerator. These new functions, a star sine and a star cosine, still satisfy that the square sine plus the square cosine is equal to 1, and it can be shown that their derivative are like those of the normal sine and cosine, but now with an added I. The star sine and cosine functions can also be expressed as the sine and cosine of an imaginary angle I theta, which in turn can be expressed in terms of the hyperbolic sine and cosine in this way. Apparently, this change makes the imaginary unit disappear from these expressions. Now, substituting I by ct and rewriting theta as w, which is commonly known as rapidity, one obtains the departing point of the hyperbolic theory of special relativity, from where the Lorentz transformations and all the relativistic effects can be derived. Fixeu-vos, doncs, què hem trobat. Hem partit de dues premisses. La primera premissa era que l'univers ha de ser cíclic, on per cíclic entenem un cicle que alterna la presència de creació amb la seva absència. Aleshores, aquest cicle l'hem expressat en termes d'un moviment circular uniforme i, tot relacionant l'absència de creació amb els nombres imaginari purs, hem trobat una expressió que s'assembla molt a l'interval invariant relativista. Això ha permès identificar la presència de creació amb l'espai i l'absència amb el temps. I això significa que aquest cicle, aquesta rotació, s'ha transformat en una rotació en l'espai-temps. I la corresponent transformació de coordenades per rotació d'eixos ha resultat ser ni més ni menys que el punt de partida de la teoria hiperbòlica de la relativitat, des d'on es dedueixen les transformacions de Lorentz, els diferents efectes relativistes, etc. Per tant, què hem trobat? Hem trobat que de dues premisses inicials hem arribat a la relativitat. I si la relativitat es dona per bona, aleshores, en principi, les dues premisses de les quals hem sortit també haurien de ser. I quines eren? Doncs aquestes, que l'univers ha de ser cíclic i que el model ontològic ha d'estar fonamentat sobre dues naturaleses diferents, el real i l'imaginari, el cert i el no cert, la presència i l'absència. Per tant, el procediment que hem portat a terme per mi no és altra cosa que una demostració teòrica de que l'univers és cíclic. We will see now how the Lorentz transformations can be obtained, and by the way, we'll also see that relativity also displays a wave character. From those two expressions that represent the axis rotation transformation, we need to consider two particular rotations. The first is the rotation that causes the time axis to be on the point. This is a rotation of theta angle equal to alpha minus half pi, and once on the point, the x' coordinate will be identically 0. Substituting these two values, x' equal to 0 and theta equal to alpha minus half pi, in the first of the expressions, then by isolating x over t, one obtains an expression with dimensions of velocity, which, after some calculations, can be expressed as a function of alpha. Let it be called velocity v sub p. The second particular rotation that we need to consider is the one that causes the x-axis to be located on the point. In this case, theta equals alpha and t prime equals 0. Substituting these values in the second expression, we can isolate c squared times t over x, so that we find another expression with velocity units. Let it be called velocity v sub g. Note that v sub p and v sub g are defined in such a way that their product gives c squared, which also happens with the phase and group velocities of an electromagnetic wave. That is the reason why the subscripts p and g were chosen. Now we take the latter case, the one corresponding to the velocity sub g. Let its definition be squared on both sides. Then, with the help of the trigonometric expression of squared cosine plus squared sine equals 1, we can end up isolating both the star cosine and the star sine functions as a function of v sub g. And since the v sub g is defined in the case theta equal to alpha, these expressions are also the star cosine and the star sine of theta. Finally, to find the Lorentz transformations, one only needs to replace these expressions in the axis rotation transformation. To conclude that v sub p and v sub g are indeed a phase velocity and a group velocity, we differentiate the relativistic invariant with respect to the time. Note that the result of the derivative gives exactly c squared times t over x, which is precisely what we had defined previously as the velocity v sub g. Therefore, v sub g is also the derivative of x with respect to t. If we group these results, we have that x over t is the velocity v sub p, and the derivative of x with respect to t is the velocity v sub g. If we compare these two expressions with the phase and group velocities of an electromagnetic wave, we get to the conclusion that indeed b sub p and b sub g are a phase and a group velocity respectively. These results will be useful for later chapters. Thank you very much.